Okay, now that we've set it all up, we can start to deal with the solver screen. So we go to data, we go to solver, and we have to determine where our objective is. Our objective is right there, P23, and we're trying to minimize. And the variables that we're trying to change are all the x's, and we'll put a comma, and all the y's. And now the constraints, for the constraints, we may want to first look at, we got the objective. So now let's look at C1. Let's do them in that order. That C1 has to be greater than dt. Okay, so we don't have dt in our spreadsheet, not right now, but we sort of do. So let's think about this a moment. So we have for every t, the sum of the pi yi's plus 500, which is this right here, has to be greater than the demand. So let's do that. Let's add that these here have to be greater than or equal to the demand. Now the demand is sitting somewhere else. The total demand is sitting in here. So we highlight that and we add. So we've just added that constraint, C1. Let's go to C2. Now we have to deal with C2. C2 deals with xit's across the sites being less than 1. So that's this sum here. So the cell reference will be this to that to the bottom, and this will be less than or equal to 1. And we'll add that. And next thing we'll have C3, which is that the sums across here have to be less than or equal to 1. And we'll add that. We also need to add C4. C4 is that these here, so this is really I'll just cancel this for a moment. I just say let's cancel this, and let's look at our solver for a moment. And we have reflected the the constraints that we put in so far, which is C1, C2, C3. We have our objective function. We can't solve yet. Now we have that these entries here have to be a positive. So we'll call solver. We'll add that all of these entries here have to be greater than 0. We have to add also that xit and yit are binary explicitly. So that means that all of these we'll have a separate one for the x's. We'll add that, and then we'll have one for all the y's, and we're okay. And we believe we have them all, so we need to change the solver to simplex LP, and we now press solve. And the problem is too large for solver to handle. So we have formulated a nice big problem for determining the power plants that should be put in service in the next 20 years. And this is not too far from a real power, needed real exercise that used to go on in the province. But it's too big. And so we have a few options. One option is to reduce the time frame to 10 years and try again. The other second option is to use a product called OpenSolver from opensolver.org, which some students like. And the third option, which is the one I recommend, is that you install the Solver premium version, for which you need to specify a course ID and a text ID that I will post. I will be installing it on my computer. I just received the email about 10 minutes ago that they've granted us a license for the course. They point out that many students don't read the instructions and cause them all kinds of calls and problems that need to sort out. So there's two things they point out in their instructions. Number one, please read them carefully and follow the instructions exactly. That will minimize your aggravation and their aggravation. That's one. And two is that if you have a Macintosh, that you do not try to download the version, their version. The difference is that you will get you'll run into difficulties. Most of their technical support questions have to do with Mac. So what they ask you to do is to run the Solver version on Windows on a Mac. I don't know enough about that, but they have instructions for students who have Macintoshes. Okay, so we're gonna have to live with this for now and then come back.